Most people begin their day with washing their face, brushing, and making some breakfast. In one way or another, we interact with water from morning to evening. That is why it is very important for us to ask ourselves, what is water? Hello there, welcome to High School Tutorials. Behind the screen is your one and only science enthusiast, Mr. Stanley. Well, water covers over 71% of the Earth's surface, more than the land we humans live on. Here is a globe of the Earth. Every blue part that you see is the part that is covered with water, and we haven't even talked about the dams, the lakes, the rivers, the boreholes and the wells that we have in our nations. Therefore, water covers a great amount of the Earth's surface. Some common sources of water include wells, boreholes, dams, lakes, and seas. But I have a question for you. Do you think rain is a source of water? If yes, why? And if no, why? There are still other sources of water called hydrocarbons. Hydrocarbons are compounds made up of carbon and hydrogen as the main elements. Examples of hydrocarbons are candle wax, paraffin, kerosene, and natural gas. Natural gas is the gas that you use at home for cooking. Here is an experiment to show how hydrocarbons burn in air. Candle wax burns to produce carbon dioxide and water vapor. The two products are trapped using the inverted funnel. Once they reach to the first test tube, the cold water in the beaker cools the water vapor, therefore the water collects down in the test tube. Carbon dioxide continues to the second test tube where it is bubbled through lime water or calcium hydroxide. When carbon dioxide is bubbled through lime water, it forms a white precipitate. That is the confirmatory test for carbon dioxide. Therefore, candle wax burns to produce water and carbon dioxide just like all the other hydrocarbons. The two observations made in this experiment are a colorless liquid that turns white copper 2 sulfate to blue is formed in the first test tube and a white precipitate is formed in the second test tube. Candle wax burns in air to form water and carbon dioxide. Water is tested using two ways. The first way is passing it through anhydrous copper 2 sulfate, which changes from white to blue. And the second way is passing it through anhydrous cobalt 2 chloride paper, which changes from blue to pink. Those are the two ways for testing for presence of water. Carbon dioxide on the other side is tested using lime water or calcium hydroxide. In presence of carbon dioxide, lime water forms a white precipitate. This white precipitate is called calcium carbonate. The reaction for the formation of calcium carbonate is as follows. Calcium hydroxide reacts with carbon dioxide, forming calcium carbonate and water. Now let us talk about reaction of water with metals. Water reacts with reactive metals to form metal hydroxides and hydrogen gas. Examples of reactive metals are potassium, sodium, and calcium. Magnesium reacts with air to form a protective oxide layer, which prevents it from reacting with water. Therefore, it is important to remove it before reacting magnesium with water. It can be removed by cleaning the magnesium ribbon using a knife edge or a sandpaper or a steel wool. Here is how potassium reacts with water. And here is how sodium reacts with water. So, reactive metals react with water explosively, and the experiments might be dangerous to try in the laboratory. But here are the equations for the reactions. Potassium plus hydrogen, you form potassium hydroxide and hydrogen gas. Sodium, you form sodium hydroxide and hydrogen gas. and calcium, you form calcium hydroxide and hydrogen gas. You can try and write the equation between magnesium and water. Now let us talk about the reaction of metals with steam. Some metals do not react with cold water, but they can react with steam. Metals react with steam to form their respective metal oxides and hydrogen gas. Note that in both reaction with cold water and steam, there is production of hydrogen gas. The difference is, when you are reacting with cold water you form metal hydroxide, but when you are reacting with steam you form metal oxide. Here are some equations. Calcium plus steam, you form calcium oxide and hydrogen gas. Magnesium, you form magnesium oxide and hydrogen gas. Zinc, you form zinc oxide and hydrogen gas. Other metals such as potassium and sodium react very explosively. Do not attempt. That marks the end of our video. What we have learned today is the sources of water, products formed when hydrocarbons burn in air, reaction between metals with water and steam, and so on. So go and read further, and if you really want to read further, I have some notes in the description together with an assignment that you can attempt and submit for marking as guided in the assignment. Thank you so much for watching. In our next video, we are going to talk about hydrogen gas, how it is prepared and how it is used. For now, all you need to do is to press that subscribe button, that like button, and don't forget to share with someone that you love or you care about. Bye.